Welcome to The Explainer, where we break down the big ideas. Today, we're diving into something huge, a claim that might just rewrite a couple of centuries of math history. Seriously.
So what if a mathematical impossibility, something that's been accepted for 2 whole centuries, was just a big misunderstanding? Imagine that. The idea here is that the problem wasn't that the math was unsolvable, but that the tools we were using were just, well, not up to the job.
Okay, so to really get why this is such a big deal, we need to take a little trip back in time. We've got to talk about a super famous and notoriously difficult problem in algebra. You've definitely seen these before. Polynomial equations. They're these basic building blocks in math that show up everywhere, from figuring out the path of a thrown ball to modeling financial markets. Now, finding their exact answers, what mathematicians call their roots, is super important. But here's the catch. The more complex they get, the harder it is to find those roots, like way harder.
And for centuries, mathematicians were on a roll. They figured out how to find exact solutions for second-degree equations, then third, then fourth. It looked like they were just going to keep on going, right? Just a matter of time. But then, they hit the 5th degree. And they didn't just stumble, they hit a solid brick wall.
And this wasn't just, a temporary setback. This wall became a law, a fundamental rule in mathematics. It was a line in the sand that, for 200 years, everyone was told was impossible to cross.
And in 1824, it was set in stone, the Abel-Ruffini theorem. What it basically says is this: there is no single, general algebraic formula, using the standard tools like adding, subtracting, multiplying, dividing, and taking roots, that can solve every polynomial equation once you get to the 5th degree or higher. It's just not possible, period.
Just look at this timeline. You can see the progress ticking along for centuries. And then, bam, 1824. It all just screeches to a halt. The quest for that one-size-fits-all formula, it's over. For almost 2 centuries, this was it, the end of the road.
And this is the really crucial part. It wasn't just that mathematicians gave up or got stuck. They had a mathematical proof that told them it was impossible. It wasn't a challenge anymore, it was a dead end. This theorem literally defined the limits of what algebra could do.
But what if the problem wasn't the lock? What if the problem was the key all along? What if the very tools everyone was using were the thing holding them back?
And that's where Professor Mourad Sultan Ezouidi comes in. He looked at this 200-year-old fact and said, you know what? I don't buy it. He basically argued that the so-called impossibility wasn't a rule of math itself, but just a limitation of the way people were thinking back in the 19th century.
And this table really lays out his whole argument. On one side, you've got the classical methods that just hit that wall. But on the other side, you have Ezouidi's claim that he can get exact, perfect solutions. How? Well, he's not playing by the old rules. Instead of using the traditional approach, he uses something totally different, something based on what he calls recursive discriminant structures. It's a fancy term, but it's basically a new way to break the problem down piece by piece into simpler, repeating patterns. Okay, so how does this new method actually work? Well, the genius of it is that it doesn't even try to do the thing that Abel proved was impossible. It's not looking for that one magic formula.
Yeah, it completely bypasses the old way of thinking. Instead of searching for a single key that fits all locks, it's more like a set of instructions, a step-by-step process for picking any lock that isn't tied down by those old rules.
The real game changer here is the process itself. First, you find these hidden relationships, these symmetries, hiding inside the equation. Then you apply a kind of repeating process. That's the recursive part that simplifies the problem one layer at a time. It's like peeling an onion. You just keep going until finally you can pull out the precise, exact answer.
And let me tell you, this is a huge deal. For 2 centuries, the best anyone could hope for with these equations was a really, really close guess, a long decimal number that was almost right. But Ezouidi is claiming he can get the perfect answer, the actual, verifiable algebraic solution. It's the difference between close enough and 100% correct.
And get this, he didn't just tackle a 5th degree equation. No, his work lays out a complete, exact solution for a 9th degree polynomial. That's something that, according to the old rules, wasn't just impossible, it was impossible squared.
Okay, let's zoom out for a second. If this claim survives the peer review process, and that's a big if, it has to be said, the implications are staggering. We're not just talking about solving one math problem. We're talking about changing how we think about all problems.
It's a direct challenge to this idea of mathematical fatalism, this belief that some things are just inherently unsolvable, that some doors are permanently locked. What this suggests is that maybe those permanent walls are really just the limits of our own imagination at a given point in time.
So what we're seeing is a major philosophical shift. It's about rejecting the idea that there are built-in limits to what we can solve. It's proposing that maybe every single equation, no matter how ridiculously complex it looks, holds the secret to its own solution. We just have to be clever enough to figure out how to read it.
And that's really the heart of it. This isn't just about finding an answer. As the claim goes, this discovery does more than solve an equation. It redefines what it means to solve. It takes what was once a hard stop, a historical boundary, and turns it into a wide-open frontier.
Which, of course, leaves us all with a pretty mind-bending question. If a 200-year-old mathematical impossibility can potentially be shattered, what other impossible things are out there? What other established limits in science, in technology, in our everyday lives are just waiting for someone to come along and look at them in a completely new way?